Welcome back to Coronavirus Conversations. We didn't name that, but I like the name. I saw that on the website.
I like
Um,
that too, yeah.
I like that. So Coronavirus Conversations. So, and that's what we're trying to do here. We're trying to have a conversation. I guess we're considered sort of experts. Versus I guess the sort of the um, average person off the street. I don't necessarily feel
I'm
like an
calling you
expert.
I'm calling you an expert, Adam,
Okay.
just to
Well,
clear.
then I'm calling you now. Okay. Um, yeah, I mean, so just as a quick aside, Josh, this hasn't come up yet. So I mean, I teach virology. I'm trained in it. I do research on a virus. The virus I work on is called mousepox. It's a member of the pox virus family. And one reason I study that out on Albright's campus is it's safe to work with undergraduates. It's not a human pathogen or anything like that. But I've learned a lot about coronaviruses over the years, and of course, keep reading about it now with the pandemic. So, trying to draw on that knowledge, I guess. So yeah, so this is episode number 5. All right, well, welcome, and thanks for viewing. So we're gonna open up today. This may end up being an all email episode, which is totally cool. So thank you to the people who have written in. So our first discussion point um, will be related to an email that we received, and Dr. Williamson is going to tackle that one. It's very much medically relevant. Okay, so I'm just going to read through this. So this comes from a member of the Albright community, and I'm not going to mention the name just to remain anonymous because there could be some potentially sensitive information in there. Okay, so quote, there's a lot of talk about high-risk people being elderly or people with pre-existing conditions. Then we have pregnant women. I'm particularly interested since my daughter is currently pregnant with our first granddaughter. Well, congratulations. So my daughter is 24. She's young. She's otherwise very healthy, but considered high risk. Can you touch on that a bit? Why does being pregnant make her higher risk? Is the baby in her womb also high risk then? In parentheses, being a child who obviously hasn't been exposed to any prior coronaviruses. Does this just mean that her defenses are down, so she's more likely to contract the virus, or is she more likely to get more severe symptoms because of her pregnancy? Okay, Josh, so what do you think?
So it's a very good question, and that's a big question that come very early on with as soon as this virus was identified, because pregnant women are at higher risk for issues with flu in particular, and so there was concern that there would be issues with this virus as well. Of course, Zika is also a new issue on the board for us in medicine, and that causes major problems in pregnancy, causes problems with the developing babies. And so there was concern that there might be issues here too. There was a lot of good reassuring data that came out of China early on, as far as not only not affecting the virus, not affecting children as severely, but also not affecting babies. There was some small case reports of pregnancies that occurred during the pandemic in the early phases, and everything was very reassuring. It, it at this current point, it's the virus is not thought to be transmitted from mother to baby in a vertical, what we call vertically. So it doesn't go from mom to baby in the womb. So, but we do worry about the transmission afterwards. If mom's positive, she could, of course, spread it to baby because they're obviously going to be in close contact. Again, very small numbers on these studies, so it's tough to draw some conclusions. And again, we'll have more information as things go on. There have been some concerns, though. Lately, I actually answered this email last week, and then the very next day, I read up on a couple of additional studies. So there are now some concerns with pregnant women that seem to or are probably related to the changes in the coagulation state of the mother. That's a problem that we're seeing in patients in general.
Josh, are you speaking of pregnant women who are coronavirus positive?
Yes,
Yeah,
yes,
okay. I just want to make sure that I was following. Okay.
right. Um, so, so that's something that's come up as a concern. There's been a couple reports of miscarriages in pregnant women that tested positive for COVID. Now that we don't know whether or not that's going to happen. It's very sad, but miscarriages happen every day, and so these we don't know how much higher risk pregnant women that are positive for COVID-19 actually are, and so these few case reports you can't jump to a lot of conclusions with that. But
Josh,
obviously that's something.
is it true? So I've heard over the years that sometimes an infection, just in general, right, can potentially cause a miscarriage. Is that accurate, or is that sort of like a old wives' tale type of thing?
No, I think that's I think that's considered accurate. Again,
Like if you get a fever, let's say, your body's fighting off, you get a fever, etc., and there's a high rate of miscarriage. That's what I've heard. So
the problem there is that pregnant women get sick all the time. So it's very difficult. Just like with what we're dealing with right now, when people get an illness and they recover, no problem, then they're kind of not counted in the in the ranks. When you have something that has when you have a patient that has severe illness, then of course everybody takes notice and tries to figure out what's going on. So, but yeah, I do. I'm of course, I'm worried more about the babies than the pregnant women as a pediatrician.
mm,
So I'm definitely more up on what happens after the baby's born than during the pregnancy. But I do think that that's an accurate statement, Adam, especially
okay,
when it
so
comes to certain illnesses. Again, like I mentioned, flu.
right, okay, so okay, good. So at this point, there's no evidence that it crosses the placenta, potentially just because it is an infection in general, maybe a slightly high rate of miscarriage, although those numbers are very early and it's really not known. Okay, all right.
And then the biggest thing with pregnancy is what happens in the hospital now, because the hospital situation has changed so dramatically. So,
Mm,
it's a big, and that's being, it's starting to be more formalized as far as consistency across the board. But early, just as of the last couple weeks, there's been different hospitals doing different things when it comes to when the baby's born. So right now, it is recommended that there's a discussion with mom about what's going to happen.
mm,
Is the baby going to stay in the room with mom if she's positive? Again, this is all if she's positive. But even if a mom is negative, there's going to be less visitors in the hospital. There's going to be um, additional additional safeguards for hospital staff during the delivery and everything else. So it's a different landscape for a mom to deliver now than last year. There's a very brief article about just a viewpoint from I think she's an ER doctor that delivered, and she just kind of talks about how different the hospital situation is as a patient, coming from somebody that's been around the hospital her whole life.
what are the current recommendations for like labor and delivery, in terms of the infant being in the same room, etc., with the new mom?
So, there's been a big change over the years as far as we don't typically bathe the babies right away anymore. That used to be babies would be delivered, they would be taken back to the nursery, taken away from mom for a little bit, bathed, and then brought back out and kind of represented to mom. And we don't, that's not standard of care anymore. But if mom's positive, now we go back to that to where the baby's uh, I think anyway, for most hospitals have adopted this
Okay.
to bathe the baby initially, and then also then mom has to wear the mask. There was concern about additional breast care if mom's going to breastfeed,
Hmm.
to wash the breasts, wash her hands, wear the mask. And early on, it was actually recommended that the moms express breast milk, and then a COVID negative caregiver feed the baby through the bottle, just so that there was less contact with mom. That's been moved away from a little bit. Um, but everybody was kind of trying to do what they
Yeah,
thought was best early on.
absolutely. Yeah, absolutely. I remember when my two little ones were born, it seems like just yesterday, but the whole like skin to skin and all that is stressed now, which is very good. That early bonding seems to be very important. And so I remember literally like Delaney and Grant, they literally just came out, put right on, my wife's chest, and then I remember cutting the cord, and then, they basically, our kids never left the room during the entire, like we moved to the recovery room, or whatever they call rest and recovery room for a day or so. And yeah, I mean, never left our side, which is great. So, but this might change some of that, which is unfortunate, but you're trying to maintain that balance of like what's best for the child, what's best, in terms of the nurturing aspect and, the bonding aspect. But also trying to make sure the kid stays COVID negative, I guess. Okay, did you want to add anything else? I think that was a good overview of kind of what's known right now. Anything else on that?
I don't think so.
Awesome, thank you, Josh. All right, so email number 2. So this comes from Beth. So, and once again, she's a professor at Albright. And her email says, as the weather gets nicer and states loosen outdoor activity restrictions, what do we know about the risk of spread while exercising outdoors? Say 2 runners who pass each other in less than 6 feet, or bikers moving at an even faster speed. So, Josh, I'll throw it to you initially. What do you think? What are some thoughts based on what you've read and understand here?
It really is a very good email, and kind of right on the heels. I don't know if Beth read the same articles that we did, but I, I believe it was from Belgium, but it may have been somewhere else. You can correct me if I'm wrong on that,
It's
Adam.
it's
But
hard to keep track, Josh. So don't worry. Yeah.
yeah. So there's definitely the concern that obviously when you're exercising, you're breathing heavy. When you're running, you're moving. And so you're more likely to have fluids expressed from your mouth and nose, and those whether they're respiratory droplets or
Mhm.
aerosols are going to hang in the air at least for some period of time. Hopefully, very briefly.
Right.
Um, but this initial this paper that we saw talks about how as you're running or as you're biking that spray kind of comes behind you. It seemed to be an interesting when I read the article, it seemed very interesting how they did it. I don't remember the details offhand, um, but definitely it seems to be a concern. So if you're a competitive runner, you're supposed to stay kind of in the stream of the person in front of you and kind of use that to your advantage. But
Right.
that definitely seems to be a concern right now.
Yeah. I mean, if it were me, I would absolutely avoid running directly behind somebody, even if it's more than 6 feet, because you're literally in that sort, almost like a jet stream of sorts, like right behind, right? So.
I've done a little bit of running myself now over lunch breaks, a late lunch
Hmm.
break, and I mean, I see people in front of me, and I just run across the street.
Yeah.
Luckily, there's not a lot of traffic here right on campus, and I just stay away because I do worry about that. It's funny the mindset now that you get with other people. You see other people, and you see them as a threat,
Yeah.
which is it's sad.
Once this is either controlled or goes away, whatever happens with actually SARS-CoV-2, I really hope that you bring up a good point. This like awareness, right? Because if we can slightly tweak our behavior a little bit and also raise our awareness about hand washing, you know, distancing, just being aware, right? Of like, so for example, don't touch a mucous membrane, don't touch your nose, your mouth, your eyes. Wash your hands a little more frequently, um, things like that. It could have a very positive impact on rates of influenza infection, common cold infections, etc., well beyond just this particular outbreak. Because all of those things I just mentioned require, their sensory respiratory droplet transmission, just like the evidence is for SARS-CoV-2. So,
And then we can also go the other way, Adam. Just to play devil. I agree with you, but to play devil's advocate, there's some people out there saying, no, we need to keep bombarding our immune systems with things so that
Well,
our immune system
my
stays strong.
I mean, you're not wrong, and those people aren't wrong, absolutely. Um, but I know I think that we're bombarded with so much stuff as it is anyway. Um, you might as well try to mitigate your risk of getting a serious infection like flu. I mean, anytime you step outside, you're being bombarded with fungal spores and bacteria and viruses, and there's no shortage of our immune system getting bombarded with stuff. So
Billions, right? Isn't
billions.
billions every day? That's what it's funny. A lot of parents that worry about vaccines, they come and they say, "Well, how would you bombard your body with all these things at one time?" Because the kids get so many shots at
Yeah,
once. I can say it's just really a drop in the bucket compared to when
yeah, it
our immune
really is.
system
It
are
really
geared
is.
up.
Yeah, it really is. I showed this graphic to my students. I wanted to share it really briefly here because you brought up the point about expelling things. So I'm just going to share my screen and share this particular slide here. This is from a PowerPoint that I
Oh.
show my students. And I love the image here. And I also, so there's some researchers, I believe this came out of MIT. So this is from the Journal of Fluid Mechanics in 2014. The average human cough fills about 75% of a 2-liter soda bottle, and about 3,000 droplets are expelled in a single cough, and some of them fly to the mouth at speeds of up to 50 miles an hour. Sneezing produces even more droplets, 40,000, some of which rocket out at speed greater than 200 miles an hour. And that's a sneeze, right? So anyway, I mean, I think your point is well taken. If you're running, you're breathing heavier, those droplets are going to be coming out at presumably at a more higher rate, and also potentially more of them, and so it's just something to be aware of. But this is this is a dream come true for a respiratory pathogen, right? Josh, look at that.
I need to see the viral particles in there, Adam.
Yeah. All right.
It, this I don't want to. I don't know the answer to this, so I'm going to ask you, Adam. When you sneeze, is some of that then aerosolized? We talked about that a little bit
Well,
off camera.
it does. Okay, so my understanding, once again, from just reading the stuff over the years, is a lot of things in our daily life create a aerosol, and maybe this is a good time to kind of, and of course, I'm going to define this as a biologist, not as a fluid, mechanics person, an engineer, a physicist. They're going to have a better definition than me, but this is my layman's understanding as a biologist. Is when something is aerosolized, it's essentially on really, really small um, droplets in the air. Like I believe it's less than 5 microns across. So like 10 to the minus 6 meters, like really small. And then, so for example, think of like a dust particle. I mean, a little tiny dust particle can remain suspended in the air for potentially hours to days even. And so that's to me a true, like, quote unquote airborne transmission. A aerosol is something that is something that could be airborne. It's suspended, and gravity really does not pull it down very, very fast. Whereas a respiratory droplet, and there's even different size droplets, but they're much larger than that, and gravity can take hold and actually pull it down much more efficiently. So, for example, the current recommendations from the CDC and the WHO still say that SARS-CoV-2 is transmitted by respiratory droplet transmission, and hence the 6 feet thing, where if you're breathing, potentially even coughing, although it's possible, right, to sneeze, a cough, that could go more than 6 feet, right? But I actually don't know where the 6 feet comes from, but the idea is that these droplets, they're much larger, and when they come out of your mouth or nose, gravity can actually take hold of that, and it falls to the ground much more quickly. Hence the 8 feet thing. A true airborne transmitted pathogen. Um, this is just kind of like my intuition, and I'm making it. This is sort of not based I wouldn't say it's an informed opinion that from what I've seen. Um, so actually, Josh, why don't you jump in for a minute? Why don't you define R naught, and then that'll lead into what I was going to mention, because I don't want to I don't want to be talking too much at once.
um, yeah, so this idea that that a person that's infected will infect a certain number of people. So that's a defined number for different illnesses. For different viruses, there's a really nice graphic. I wish I would have been prepared. I think I actually have it up on my computer somewhere, but it's on the CDC with different, each well-known viruses, HIV, Ebola, Zika, flu, COVID, and with where these fall in line. Oh, I'm sorry, measles which is the classic one.
Right.
Because so I'm just from a medical standpoint, they say that if a person in the room has measles and you walk into that room after they're in there, there's a really good chance you're going to get it if you're not immune.
Right. My understanding from measles, and I'm speaking just from my memory about this, is that that's still not true airborne, I believe. I mean, it's on really, really, really small droplets, but I believe it's still droplet. It's just that gravity takes longer to pull it down because it's on a much smaller droplet than true airborne. So so that was great, Josh. Thanks for that intro. So this idea of R naught, like how many people will one infected person infect while they're sick, right? And so, Josh, what's the current number that you've seen for SARS-CoV-2?
I think it's now at, I'm not sure. Is it 3? I think
think
3
it's
is
around
last.
3. That sounds
I
right.
saw 5 initially, and then I saw 3 and 2. I think 2 to 3. I think is actually.
I think you're right. I think the current number is around 3. So let's just say 3. I mean, in my opinion, based, like I said, educated opinion, if this was a true airborne infection, that R naught value, or how many people one person is going to infect, would be significantly higher than 3. I mean, it would be, and I don't have an exact number, but it would be much higher.
I think
And so
10 or 15 even. I think is what I remember seeing.
it would be closer to measles. Like I said, I don't consider measles to be a true airborne, but it's the closest that I've ever seen to an airborne, because it's on those really small droplets. And so once again, it just takes gravity a longer time to pull it down. Whereas something that's on a larger droplet is going to be pulled down, to the ground much more quickly, and that tends to decrease the R naught value. So now, of course, we're talking here about respiratory pathogens. Something like HIV, which is transmitted through blood and other bodily fluids. That's obviously, there's really, I mean, the chance of it becoming aerosolized is significantly smaller. But any time that you breathe, you are creating aerosols. But whereas the actual virus, the current evidence that we've heard about from like I said, the CDC, the WHO, say that it is a droplet transmission, and it probably on those larger droplets, hence the 6 feet thing. Now, there's been some recent studies. So, for example, there was a paper on medRxiv, which is once again one of these preprint servers, and this is a preprint here, and the senior author is Vincent Munster, who is out of the NIH, and they do address in this paper aerosol SARS-CoV-2, but they literally put the virus in a machine to create an aerosol, to essentially make it a little more like closer to an airborne thing. And they do see that it hangs out in the air for a substantial amount of time. I'm trying to read through the abstract here. So they, like I said, they put in. Josh, go ahead.
Yeah. Now, while you're doing that, Adam, I was just going to say, they're talking now about more gentle ventilation for patients early on. So CPAP or high flow nasal cannula, and from what I understand, that CPAP does put the risk of aerosolizing the particles with that forced air happening through the upper airway, instead of when you're ventilating a patient, the ventilation is occurring deeper, so things aren't spewing out into the room or into the local environment.
Gotcha. No, that makes sense. Just to kind of as a precaution, yeah. So anyway, so from this abstract, they say that we found that viable virus could be detected in aerosols up to 3 hours post aerosolization, etc. So
And I remember there was something out of China. They were locating viral particles much further away from in patient rooms, further away from where the patient's bed was located, and so that was a concern. I I really think that 6 feet came from one of those epidemiologic studies of some of the airplanes coming back, bringing COVID positive patients. Actually, no, I'm sorry. They were bringing U.S. citizens back, and then some of them tested positive, and then they were looking at where everybody sat on the airplane, and that 6 feet radius. I remember there was a picture of a red seat in the middle and green seats around, and then the rest is.
okay, yeah.
And I think that was I think that's where that number first started, and then it hasn't really changed since then. So I
Yeah,
guess
I would agree with that, Josh. If you look at just the epidemiology of this, I would still say that by and large it's probably on medium to large droplets, or else, from what I know, I think the R naught would be significantly higher. Now, you bring up a good point about the patient room thing. I mean, you can imagine if someone's infected and they are expelling a lot of virus, they're in a confined space and they're literally sitting there for hours, just sitting there, right, just expelling virus, more and more and more and more virus, right? So to me, just the fact that it is a confined space and just the sheer amount of virus potentially that just accumulates over a period of time, maybe that can contribute to a finding like that. But once again, I'm basing my, this is an informed opinion. Okay, so was that all I wanted to say? Oh, and the last thing I wanted to mention is about, some of these respiratory pathogens are less efficiently spread in the summer. And why is that, right? So it's kind of related to this. It goes back to the droplet thing. So what I've read from, published articles, etc., is that as humidity rises in the summertime, those droplets that we expel, they fuse together much more quickly and more efficiently with higher humidity. With drier air, they tend to stay separated, whereas in high humidity, those droplets fuse together, so they make even bigger droplets and then bigger droplets. And so the bigger the droplet, the faster it falls by gravity. And so it's harder to transmit when it's higher humidity. It's not about, to my knowledge, it's not about virus stability. It's not about the actual physical virus particle being less stable, but it's more about when it's in those droplets and it's high humidity, they fuse, they become bigger, and they fall to the ground faster. So, all right, so I think this, yeah, so we'll try to answer one more email here. So this comes from Dr. Ken Cleaver, PhD. He's Albright class of 1968, chemistry. So he writes, from day one of the pandemic, we have all been told that washing your hands with soapy water would destroy the virus and greatly reduces your chances of getting the infection. This continues to be stressed by every article and newscast. You discuss that soap breaks down the phospholipid layer that surrounds the virus, right? Which I believe to be true. Can you please clarify how a virus, which is this susceptible to ordinary soap and water, can survive the prolonged trip through the GI tract with both acid and basic environments and emerge intact? Could this finding be confounded by sample contamination by the tester? So in terms of, so that's a very good observation, and thanks, Ken, for writing in. So the one question there, could this finding be confounded by contamination by the tester? I would say probably no, especially since most labs are going to probably be doing this sort of testing with some PPE on, with gloves and things like that. I mean, it's not impossible, but I would say that's highly unlikely. So actually, I just wanted to highlight briefly, I'm following some research coming out by Dr. Christian Drosten out of Germany, and he's an MD, PhD, I believe, and works closely with the clinical staff at the local hospital in, I think it's Munich, Germany. And so he has ready access to a lot of patients and samples from those patients. And what's really, really interesting is that from the moment they find SARS-CoV-2 in the airway, so once again, they're swabbing and they're putting that swab for PCR testing, so looking for a genetic signature, and also they're taking a swab from the same spot and putting it onto cells and trying to look for, is there actually live replicating virus present? Now, as a virologist, that's sort of the gold standard, in terms of, is there infectious virus present in this sample? Once again, we touched on this in episode 2 or 3, but a PCR test, it doesn't mean that live replicating virus is actually present. And so, whereas, putting it onto cells and seeing virus growing, right? Because you can actually see it's called a plaque assay. The cells look sick. You can clearly see that virus is actually replicating. It's infectious. So it's really interesting to go back to Dr. Drozden's work. And once again, this is like on a preprint server as well, is from the moment that somebody tests PCR positive in the airway, that first week or potentially 2, they do find infectious virus in those swabs as well. But then people continue to be PCR positive for potentially weeks afterward in some people in the airway. So still PCR positive, but after about a week or 2 max, they don't find any infectious virus anymore that they can actually what's called culture, right? You can culture. They have never found infectious replicating virus from a stool sample. So this is even from day 1 of being PCR positive in the airway. They also find virus by PCR in the stool, but they've never found live replicating virus from a stool sample. So once again, it depends on the test, right? Once again, this is preliminary data. So I'm going to continue to track these findings, but that is good news, right? Because we have described fecal oral transmission. It's potentially hard to control that because for people that don't wash their hands properly, or it gets out into the environment, it could stick on surfaces, etc. Just imagine a daycare setting where kids, are very dirty and they, things like that. And so some viruses rely on this fecal oral route. There's no evidence that I've seen, both from Drosten or otherwise, to suggest that it is a legitimate fecal oral transmission. But just to kind of wrap up that point, so you can see virus via PCR, but is it intact, live, replicating virus? The data from the Drosten group would suggest no. And so I would say that the virus is going to the GI tract, and it's probably replicating in the GI tract as well. But I don't think it's leaving the GI tract actually intact, actually viable. And I think some of those enzymes and conditions in that GI tract are potentially making it not viable. That is my assumption based on what I've seen so far. And so I do think soap and water breaks down the outer membrane of the virus and makes it not viable. Once you lose that outer membrane, then you can't infect another cell. And so I think it does disrupt it. I think soap and water probably does work very well. And I don't think, based on what I've seen, that, like I said, replicating intact virus is actually exiting the GI tract, or at least not in sufficient numbers to be able to culture it. Okay. Josh, did you have any comments or questions as I was going through that?
No, that was really good, Adam. I do have to wonder, maybe it's only in patients that have diarrhea symptoms.
Potentially. Yeah, and that's something that they did not mention in that paper I'm discussing.
Because only about, I think about 4% is the current quote for diarrhea as a symptom.
And that could certainly create a quote unquote aerosol, or there would be droplets, both. And so the worry is that with somebody's diarrhea, it's going to potentially spread and fill the bathroom with virus. But once again,
everything's moving through the GI tract much faster, so maybe not breaking down right. as effectively either.
Luckily, luckily, I believe the rates of like that type of GI symptom are pretty low, right? Am I mistaken or not?
Yeah, I think 4% is what I saw most recently.
So once again, not impossible that it's fecal oral, but I would still say that it's not a major route of transmission. I think the major route is still via respiratory droplets. That's not to say that if you go to the gas pump, you shouldn't wash your hands or use sanitizer. That's not to say that, you know, you shouldn't be careful about surfaces and things like that. But the evidence that I have seen suggests that, I mean, I'm just gonna, you know, throw a number. This is my opinion, my opinion. I would say potentially even 95% of all cases are probably via a respiratory droplet route. Um, because I mean, one thing that's still not clear, and people I'm sure are looking into this, what is like, what is the infectious dose? It's probably decently high. So like on the order of, so I'm going to throw a jargon out there. So plaque forming units, it's just a way to quantify virus when you put it on cells. How many plaques does it make per unit of volume? Something like flu, I've seen numbers of like 10,000 to 100,000 plaque forming units in order to actually get an infection in somebody. And so until I see something otherwise, it wouldn't surprise me if it was more than 1,000, like probably 10,000 or more coronavirus, plaque forming units. And so that, I mean, that's a decent amount of virus. It's not a ton, but it's a decent amount. It's not as if you need like a single virus particle to create an infection in a new person. So that's something else to consider as we move forward, looking at data like this. We need to know what's the sort of minimum infectious dose of virus to yield an infection in that next person. So,
And, I don't know if you can answer this, Adam, but it would something like which would be worse, a disease like measles or a disease like Ebola, as far as that number goes, that infectious.
that's a really good thought. I don't know. What do you think? And I'll I'll think about it. But I think
Kind of
about it.
thought well, as you're describing that, because I had that same question as you were going through, which I was glad you were talking about it. How efficient is that when you put a virus on the cell? When you're trying to do it in the lab. I was curious as to how successful is that? How many, when you think you have live virus and you're doing it, how efficient is that process, was my first kind of question. And then my second question was, is it a disease that moves very quickly and is very virulent like Ebola, or is it a disease that spreads very easily like measles? Which one would fall into that category? So just
Well, I mean,
that's where that question came from in my own head. I didn't mean to put you on the spot.
no, that's a good question. I mean, in terms of putting it onto cells and causing replication, I mean, you can collect, mucus and saliva from, say, somebody with measles, and I would assume you'd get cultured virus out, just like you can culture Ebola from bodily fluids, right? I mean, it's a pretty. I mean, I've never done it because I'm not like a sort of I don't work with direct patient samples, but I mean, it's something that's been going on for decades. I mean, that's like literally the tried and true gold standard. Is somebody shedding actual live replicating infectious virus, and so you can do like a little wash or a little swab, and then collect a little bit of volume, or put on the swab, you put in a little saline solution, put it on the cells. That's pretty, I mean, it's a pretty standardized type of thing, and it's I think it's getting closer to what happens in natural transmission, right? Where if there's enough virus there to cause it to grow on cells, my gut would tell me that there's enough virus to cause an infection in somebody else, right?
That definitely makes sense.
So anyway, that's just kind of my take on it. Okay, so we are both out of time, but this is great. So thank you so much for the people that that wrote in. Please write in not only questions, but if we're saying something that you think is incorrect, feel free to correct us or to offer your take on it, and we'd be happy to read your email on these videos. So we want to make sure we're also putting out accurate information. So feel free to correct us if you think we're saying something incorrectly. Josh, thank you for joining me again. I enjoy our conversations, our coronavirus conversations, right?
Yeah.
And so we will put this out early next week, and we'll do at least one more episode next week. And so thank you for watching and listening. Josh, I'll let you have the last word.
All right, sounds good. Thank you, Adam.
All right.
And I'll see you on Monday. We're doing a little, we're helping their trainers out here at Albright to do a program on Monday. So I'm looking forward to that also.
Yeah, it should be good. Yeah, it should be good. We're just trying to help to educate and raise some awareness and have some conversations about this and get people informed. So hopefully we're doing that. All right. Well, thank you, Josh. Have a good weekend.
Thanks, Adam. You too.
All right. Bye.